Hello, this is my lab 4. So as a little introduction, the purpose of the lab was to compare the actual motion of an oscillating spring with a ball attached to the end to the predicted motion, which we did through code. So the main ideas are oscillation, energy, like total energy of a system, and spring force, which factors into the motion. So the system was the ball, the spring, the earth, and the air, and we didn't have any surroundings, so we made it kind of like a closed system. And the main results were that the observed and predicted motions were very different, at least for me, but that might have been due to error. So the main physics ideas were spring force, which we used the spring force equation shown there from the equation sheet, and we put it into the code to predict the motion of the ball and its position throughout the experiment. And also energy. We use spring potential energy, gravitational potential energy, and kinetic energy to define the total energy of the system throughout the experiment. So the steps we took were to track the experiment video given to us, which is shown here. And the little red dots are my tracker. And then we also gathered position data from that, and then we edited the starter code, and then got the results with the data from the tracker and inputted it into our code, and then compared our results. So our code was like this. So this is the main part that I edited to find the energy of the system and the net force. And my initial conditions are listed there with the mass, the position, the velocity, all found either given to us or found through tracker. And the initial time was the start of the ball moving in the tracker video, and the delta t was between each frame. So to compare our results after I used the data from tracker and inputted it into the code, obviously we can see that the x position that and y position that the model predicted versus the actual experiment is very different, and not very similar at all. Oops. And possible sources of error for this were tracking incorrectly, either an error in calibration or when actually tracking the motion of the ball throughout each frame. And some more results that I got. This is the energy graph that it gave me. And to answer the question, energy principle does not apply according to this graph in my experiment, since delta E isn't 0, the orange line should be flat and at 0, since it's a closed system and no work is done on or by the system. And the kinetic energy and potential energies don't cancel each other out, which they should, so that delta E equals 0. Yeah. So then part 2 of what does it mean? So I predicted that the x position, based on the x position data, the oscillation period would be 1.14 seconds. And then based on the y position data, it would be around 1.33 seconds. And I think that it's different because of the spring component in the y direction, and gravity could be affecting the oscillation in the y direction. Okay, thank you.